underwent a couple of processes and a couple of evolution for it to be where we are right now. So for the past 25 years, GIS has transformed from basic mapping tools to advanced cloud-based systems that integrate AI, Internet of Things, and 3D modeling. This evolution has empowered industries to solve complex challenges, from disaster management and urban planning to climate change mitigation and public health. As GIS technology continues to innovate, it connects people, data, and places, shaping a smarter and more sustainable world. So basically, we can say that GIS is more than a tool for mapping. It's used to bridge people, connect people and communities so that they can address real world challenges. Yeah. So for the past 25 years, maybe we can highlight some of the key achievements that you've seen, such as the ones I have highlighted. I hope everyone is able to see. Um, One of the key achievements is growth of GIS from desktop to cloud-based solutions, integration with AI, Internet of Things, and BIM technologies, and also supporting sustainable development goals. So moving forward to this year's theme of GIS, mapping minds and shaping the future. So how is this technology making a human connection? How is it mapping minds? In the next slides that I'm going to share, you'll be able to see how this technology is able to do that. Um, as we had mentioned earlier, the technology is more than just a tool for mapping. It connects people. It acts as a bridge connecting people so that they may be able to solve real world challenges. And how does this technology do this? It does this by fostering collaboration and shared understanding. It enables individuals, organizations, and nations to make informed decisions and drive a positive change. Uh, GIS strengthens the human connection. It brings together diverse people from diverse areas. It also brings together people who have different perspectives and empower them to solve a problem in a collective way. So this is how it is shaping and mapping minds. Uh, so I was able to also share with you the impactful stories of how GIS is being able to make a human connection and shape the world. Uh, some of the stories I shared are from our blog here at Eastern Africa. We have a blog and we are able to put together a few case studies of how this technology is enabling various organizations to be able to solve problems. So from the first picture you can see, this is how GIS is being used in Kenya to safeguard endangered rhinos. If you click on that link, you'll be able to see the stories, but later on in the chat section, we'll be able to share with you a link to our blog so that you can go explore these stories and see how this technology is helping us as Kenyans, as the whole world, to be able to solve problems. So I shared a couple of stories with you on these slides, but I'll be sure to share the link of our blog in the chat section. So maybe the GIS Day was, we can say it was on 20th, but the whole week was GIS, Geography Awareness Week. So I understand people in different organizations were able to celebrate it in different ways. So when someone asks you, how can you celebrate GIS Day? You may have your own idea of how you celebrate it. But here I was able to highlight a few ways in which you can be able to celebrate your GIS Day. Maybe you can create a GIS poster and share it on your social media pages. You can host an event the way we are hosting one right now, maybe through a webinar or just an in-person event. You can bake a GIS Day themed cake. Apologies for those people who are not here because after this session, we'll be sharing a GIS themed cake. So maybe the people who are not here will just be able to see photos. But yeah, you can also bake a GIS themed cake and share with your colleagues, your friends, and all that. You can also give a speech. Like this year, we were able to send some of our colleagues to various institutions to give a speech on how this technology has empowered them. And yeah, in the subsequent posters, slides that I'm going to share, you'll be able to see how we celebrated GIS Day as East Eastern Africa. We sent some of our colleagues to various universities. You can see Kenyatta University, Maseno, Taita Taveta. We were also in Garissa County, and all over Kenya. Yeah. So maybe as I finish my presentation, I'd like to play a few videos of how we shared GIS Day with our customers. Cosa? Bado.
Thank you, Rachel, for through that presentation. I'm just helping us see how the GIS has grown in those years. And if you noticed in some of those presentations, most of them have been by university institutions. We have many institutions that sign up globally for these events, and majority of them tend to be education institutions. And so, of course, Esri supports education institutions across the globe. And to help us see this, we're very privileged to have Dr. Michael Gold, who's the Esri Global Education Manager. He's based in Spain. He sent a video to us celebrating GIS Day. So I just want to share his video as we celebrate GIS Day, as we prepare to have Ubong Udomdom from Eco Electricity Distribution Company, who will come up right after his presentation.
Hello, everybody. Michael Gould from Esri's education team, Esri Global Education Manager. Also, I'm a GIS professor in Spain. I've been teaching GIS for 25 years now. Speaking of 25 years, happy GIS Day, and we're very happy to celebrate with you the 25th anniversary of GIS Day, a day in which we come together to celebrate all the millions of applications of GIS across government, private sector, the education and the research world, people doing great things to solve problems around the world. Let me jump into a quick presentation here. And talk about a few things that we're thinking about within the education world. We're very happy to work with universities around the world. We work with more than 11,000 universities through our 85 different Esri offices. And we're working to help people to migrate to what we call modern GIS, which is a new way of looking at GIS. Of course, GIS is applied in many different fields, more than 100 different fields, including agriculture, energy, sustainability, disaster response, etc. And as educators, we need to have a good idea about what people in different industries, and here we have a web page, esri.com/industries, where one can go to learn about what are the Esri users doing in the fields of business, conservation, energy, defense and intelligence, architecture, and the list goes on and on and on. You've got about 50 different industries here, and you can click on these links and learn more about what people are doing in different areas. So it's not just the case that people are utilizing GIS to make maps in a geocentric way, but there are people who are working in a diversity of different fields and are applying GIS to become more productive in those fields. I'll skip over some of these here, but just to talk about how GIS has been evolving over the years, and I won't cover all of these, but we're moving from the idea of having a desktop software to do our own particular private geographic analysis to a more diverse, a more integrated, a more connected system of desktop with cloud, with mobile devices, sharing data, utilizing data from other partners, creating dashboards and other applications rather than only printing maps. So there are many, many ways in which GIS is changing and has changed over the years. This change looks like this in terms of types of things we do with GIS. So of course, we're always interested in web-based mapping and cartography, creating beautiful maps and powerful maps to tell stories and for decision making. GIS has always been about advanced spatial analytics, and that continues to grow. Our toolboxes of geographic analysis are growing every day, and this includes many artificial intelligence methodologies and tools. There to the right, mobile workflows. So we're taking GIS into the field, not only to look at maps, but to collect data in the field, to synchronize the data with our GIS database, to make decisions in the field with our mobile devices. Then down below, we're integrating true imagery and remote sensing capabilities within the ArcGIS platform. It's no longer necessary these days to have two systems to be talking about our GIS and then our remote sensing system. We now integrate the two. Are able to integrate directly our image analysis within our GIS workflow. This is very powerful. And then finally, on the bottom right, many, many options for us to not only create geographic information products, but then to share and to present them to the world. So many different options for creating story maps, for creating instant apps, for creating web applications, for creating dashboards, multiple ways to tell the story, not just black and white databases. The data sources are coming in from many, many different worlds, many different communities these days. So no longer are we sitting waiting for our National Mapping Authority to deliver the new cartography. We now have many other options besides, and in addition to the official data sources, we're able to fly a drone and collect imagery and to collect three-dimensional point clouds. We can take in data from real-time sensors regarding traffic or regarding pollution, etc. We're able to work with our engineers and our architects to bring in computer-aided design data and building information models. We're able to work with the analytical world to bring in data from exterior models. And so there are many, many ways for us to very quickly bring in data sources for immediate analysis with our GIS. No longer do we spend 90% of our time sourcing data, creating data, cleaning data. Now we have many, many analysis-ready data sources that we can readily bring in to our GIS workflow, and that's really important to us. So with regards to cartography, we've always been focused on creating, as I said, beautiful maps and powerful maps for making decisions. We're not just talking about sort of your typical formal maps that we're going to hang on the wall, the type of maps which will take a month to prepare with lots of fine details. We're also talking about maps which are more quickly designed and put together utilizing smart mapping capabilities to be able to tell certain stories. Thematic cartography, which can be incorporated into web applications and your websites to be able to communicate certain activities in the world quickly and powerfully. So all sorts of different cartography. This is what we're thinking about these days in terms of modern GIS when we think about cartography. Not only static maps to print and hang on the wall, but also three-dimensional animated maps, bringing in data in real time. In this case, noise data, but it could be traffic data, it could be weather data, etc., to be able to understand our world in near real time. Spatial analysis. So this capability is growing, and I won't go into much detail, but I think you understand what we mean by spatial analysis. Importantly, is that we're bringing in more data from imagery. We have the powerful remote sensing capabilities. I mentioned the data sharing, which we hope that you're incorporating into your learning and into your research activities to be able to not only create interesting results, but then to repackage them for non-scientific purposes, to be able to push out as applications, as dashboards, as story maps, such that you can communicate with more people. An example of a story map. We hope that you're utilizing mobile devices to get out into the field, to collect data, to build that in situ data collection process into your GIS workflow. With regard to the spatial analysis that I mentioned earlier, GeoAI, of course, is a huge topic, and this is a large focus of our company these days, is including pre-trained models, including capabilities, not only in terms of GeoAI for feature recognition and other sorts of algorithms on imagery and other data sets, but also generative AI in terms of smart assistants that can help you find the right data and it can help you find the right methodologies to do your work. In terms of GeoAI, we offer nearly 100 pre-trained models for deep learning. This will allow you to utilize the models as is for doing things such as extracting building footprints or trying to identify elephants or parked cars and all sorts of different objects. These models can be retrained and it can be reinforced with your local data, bringing in new imagery or new data sets to be able to retrain the model to improve the results. And we'd love to help you to do that. Many of you are thinking about doing more programming. And of course, that might mean JavaScript for web applications, but primarily in the scientific field, it means integrating Python programming or scripting within your ArcGIS platform to be able to create extensions to the platform, to be able to connect to third-party models and other software. So we have many, many different resources to help you to get up to speed on programming. We offer a bridge to the R geospatial statistics world. So you can, from your ArcGIS platform, from Pro, for example, bring in this new toolbox, be able to call R routines, run those routines, and bring the results into your GIS workflow. That's very powerful, and we encourage you to take a look at that. The Living Atlas of the World is the world's largest collection of curated geographic information, many, many different global data sets, such as elevation, imagery, soils, ecosystems. The list goes on and on and on. This is not a closed system. It's a system which allows you to propose and to upload data, and we can do the curation and we can host data if it's of interest to a larger audience. So think about that, and the Living Atlas of the World is really powering the modern GIS workflow. The Africa GeoPortal is one of many geoportals that we're now creating for different regions around the world, and this brings together a community of users, and it brings together curated collections of data, curated learning activities, curated geospatial tools. And we'll be utilizing these portals more and more as a nexus or a place to bring people together for hackathons and for other kinds of competitions and activities in the future. So please have a look at the geoportals. Closing here, Esri offers a giant selection of products and methodologies for a diversity of GIS workflows. We understand that not everyone can understand all of these, can utilize all of these. That's part of our role in the education team, is to help you to decide for some particular learning activity or for some particular research project, which products and which methodologies are best for you to utilize. And we can help you to pick and choose like we do at the buffet at a nice restaurant. We don't need to eat it all. We need to decide what we'd like to focus on. And again, that's our role, to help you to be selective and to utilize and to learn and to exploit just the right tools at the right time for your purposes. So again, great to be celebrating GIS Day with you. We're very happy to be supporting more than 11,000 universities around the world. Please do contact us at the education team at Esri and through your local Esri offices, and we'd be happy to reach out and to help you to be more productive in the future. Okay, enjoy.
So that was Michael Gold taking us through. And I've seen some questions in the chat as well by Habonimana Davis. We'll answer you in the chat. But in the interest of time, I want to invite Ubong to take us through his presentation. Ubong, please confirm if you're able to share your screen.
I can hear you. Good afternoon, everybody. Please confirm you can hear me.
Loud and clear.
Fantastic. All right. Thank you very much. Thank you, everybody. The planning team, I want to thank you too for inviting me to, make a presentation. Actually, I'm going to be doing something, a case study from Nigeria. I know majority of us are Eastern Africa, practitioners, like GIS practitioners in East Africa. But we have some few people from West Africa to join in. So thank you for the opportunity. So at this point, I will be sharing my screen. Please confirm you can see my screen.
We can see your screen.
All right, thank you. All right. Seconds. Great. All right. Thank you very much. Thank you, everyone. So as initially mentioned, my name is Ubong Ezekiel Ododo. I'm the GIS coordinator for Eco Electricity Distribution Company, Lagos, Nigeria. So today I will be taking us through geospatial solution in utility management. Case study in Eco Electricity Distribution Company, Lagos, Nigeria. So my details are here. You can follow me on LinkedIn and reach out to me if you have any question that we cannot answer here. We can always connect. So just like the previous, speaker said, that GIS has actually expanded, through the has like into diverse sectors. It has expanded into uh, using data analytics, going into programming, doing a lot of things, even into high level, data computing, including artificial intelligence. That is what we call GEO AI now. So GIS has been, used in diverse sectors, and the electricity sector is not left behind. The power sector is not left behind. So its continual usage across has, made it very, very important, technology, a very important technology that cannot just be, pushed away. That is because if you go into technically, the engineers use it to, carry out their design, network planning, and even energy estimation. It's what we now call utility network. And then also talk about executive reporting. With ArcGIS dashboard, management is able to, view their reports and quickly know the numbers at the tip of their fingers and carry out executive decision that they want to make. So this goes on and on into diverse aspects of the, electricity sector. On the commercial part of it, the number of customers that are connected to the grid, customers that should be built, customers that should not be built, customers that are close to a distribution transformer, all these things, GIS has been able, to really, really help to solve problems in those aspects. So for this presentation, we'll be talking more on, our journey in electricity, uh, from paper maps or just manual data to digital apps and dashboards that we are now using. And then also talk about how we've deployed GIS, to solve problem of customer to transformer and then the feeder mapping. I'll explain more on that when it starts. Then we'll also talk about grid assets interactive dashboard. How we've designed a dashboard of all our grid assets for our management and even for our internal stakeholders. That is people from other departments, the commercial team, the network planning team, the regulatory team, and others. How they have been able to utilize this dashboard that GIS has provided, has helped us to provide. And then we lastly will gist about predictive and preventive asset, maintenance using GIS. Just a brief information about Eco Electricity as an organization. We are one of the largest power distribution company in Nigeria. We deal more on the downstream sector of the value chain of energy. So we distribute to customers. We have over 600,000 customers with, geographical, boundary of about 1,900 square kilometer. And then we take about 15% allocation, of the total grid from Nigeria, that is factored, push into the network in Nigeria. So we are actually a major player in the electricity sector in Nigeria. So how have we moved from using paper maps or manual, tools to digital apps and dashboard? This has been very, very effective. GIS, like earlier mentioned, has been really, really, effective and useful to us. It got to the point that our management had to approve the use of, our ArcGIS enterprise, which is very, very expensive. If an organization doesn't gain anything from a kind of a solution, they wouldn't want to invest more in it. But because they are gaining and they are making use of it in decision making and in all parts of the business chain, then they had no choice than to support us. And then working closely with the commercial teams also help us to achieve more. So moving from paper, previously our network planning team used to use maybe AutoCAD paper and, hand drawn network to do their work, which tend to introduce a kind of inaccuracies, into their work. But with the advent of GIS and with the deployment of the digital apps such as field maps, our ArcGIS dashboard, and quick capture, and a lot of other instant map, they are able to, on the go, in real time, carry out their field planning. That is, they can stay in the office and even plan their network before getting to the field. It makes life very, very easy for them. We'll move on. Previously, we were using ArcGIS Online before we moved to ArcGIS Enterprise. Why did we move to ArcGIS Enterprise? Enterprise enables a lot of our stakeholders, to have access to our central data. Apart from the fact that we control our data within the organization and everything is hosted on a server, which is a major difference between ArcGIS Online and Enterprise. On the other hand, Enterprise gives us the leverage, to create different accounts for our stakeholders, the commercial team, the regulatory team, a lot of other stakeholders, network planning team, even our consultants. They make use of this data, to carry out their work, their analysis, and it helped them to achieve a lot. So you can see that planning, designing, reporting, and making major decisions now boils down to what? To data. And who is the owner of the data? GIS. So then it makes us powerful, because if you control data, you control a lot of things. So people run to you for solution, and if they come and the data you're providing is accurate, makes life easy for them. You become the big man in the system. So GIS has really played that critical role and has made, life easy for our organization. So how did we now deploy it in terms of connecting customer and distribution transformer up to what we call feeder mapping? So the next page will show a more detailed diagram of what we refer to as feeder, and then transformer, then up to customer level. But on this particular map, the tiny point, if you look at the legend, represents customer, and then the green bigger one talks to the transformer, and then the red lines, and the green and others, they all talk to feeder. So if you look at the map very well, you see that a transformer is connected to a feeder, and that feeder is coming out from a substation, what we call a substation, distribution substation. So it flows that way. Then you have customers, being fed by this transformer, connected to a transformer. So it's just like a tree. For some people for some of us that did hydrology, it's just like a stream, with different, tributaries. So with this, GIS provides several tools, geoprocessing tools. So one of them that is very powerful is what we call the near to kind of proximity analysis. So you can use a point to determine, the distance from that point to maybe like 500 meters, 1 kilometer, 10 kilometer. Then you determine the extent, of coverage. So we're able to use this tool to achieve a lot. That is just one of them that we've been able to use. So what did we use it for? So we had issues whereby the regulators were receiving reports from customers across the country that they were, being billed wrongly. People that are supposed to enjoy 24 hours, and people that are billed separately. People that are supposed to enjoy 15 hours supply, that is electricity, are billed separately, and some 10 hours. So you have people enjoying 10 hours being billed on 24 hours ban. That is a major problem. So an organization in the system in the country was one of the distribution company was actually fined up to the tune of 200 million, which is about, that is 200 million, that should be about $200,000 now. So if not, is it? No, think about, yeah, around that. So that had a significant effect, not 200,000, I think $20,000 or so, based on the exchange rate. Is very dicey now. So that helped us to do what? We were able to use GIS in our own organization to determine a proximity level, a kind of using a threshold of about 500 meters away from each distribution transformer, that customers would always revolve around a distribution transformer at a circumference of about 500 meters. So if we have 500 meters, and then from a distribution transformer, every customer that revolves around it is likely, there is a high chance of being connected to that transformer. So we did that and it helped us a lot. We were able to build our customers based on the transformers they are connected to and based on the feeder that they are connected to. So that really helped us solve a major problem. So what did it do? We were able to determine the tariff band of each customer based on their location using GIS. And it also ensured accurate billing of our customers. So much reports were not coming, although, we have some patches of, reports coming in that, oh, I've been billed wrongly, but it wasn't as high as that significant, as compared to, what was earlier reported at the time we started using GIS to achieve this. And then it improved our customer satisfaction. Obviously, when you have electricity as a when you are supposed to have it, you'll be happy because obviously you're paying for what you are using. You are not being billed wrongly. So this is the asset model that I mentioned earlier. So if you look at the map, you'll see that we have a yellow box here. Please confirm you can hear me. Is someone listening? Hope I'm not flying alone. Hello?
We can hear you.
All right, thank you. So the yellow box here talks to what I mentioned earlier called substation. Within the substation, we have a line coming out of it. Then the small dotted line, the points you have on the lines are the poles. So in your streets, if you look outside, you see if you live in a place where you have what we call overhead lines, like electricity lines passing. So that line is modeled this way on our system. So you can see the poles as represented as points. Then the green star and the red star talks to the distribution transformer. So this is how energy flows from the substation out through the lines down to the distribution transformer. And the customers are around every distribution transformer. The customers is just simply myself and you that use electricity. So we move to our grid asset interactive dashboard. So we're able to design this dashboard for both internal stakeholders and to some extent external stakeholders that had interest in our data. So we're able to provide this because to management too, and it gave them real-time insight into what we have. They were able to know the total number of distribution transformer, total number of what we call feeders, total number of customers, everything, was there. And what made it slick was it is interactive. So it's an interactive system that you can click it and get anything you want. You can search for assets. You can know the capacity of each substation, so these numbers helped a lot in decision making. So it provides at a glance visibility for all our assets. It shows trend analysis, in terms of reports. And obviously, a lot of us make use of dashboard. So on the dashboard, you can see a trend analysis, meaning if you want to know the total number of distribution transformers that we brought into the company, you can use date function and then you see it. If you want to see for the last 3 months, you can do that and then you get it. So real-time summary and monitoring of major grid asset, which is what I've already mentioned, and also add in grid asset data search and retrieval, enhance decision making as well. So this is the dashboard that we created for our organization. This dashboard has been used by both the executive management and our internal stakeholders. When I mean internal stakeholders, other sister departments like network planning, commercial team, regulatory team, they make use of this data and they make informed decision. As at when this screenshot was taken in September, we had about 12,874 transformers within our network. As at now, it is more than this. It's almost 13,000 now. So it shows that grid, that that trend analysis is a cumulative something and it is real time. So whatever happens to it is already being seen in real time. So as time goes on, it moves on like that. So what we now call predictive and preventive asset maintenance. So we had situations whereby our assets were frequently failing. When we talk of failure, we are not talking of a fault on a system, on a transformer. We are talking of total outage. So a failure is total outage. That system is down, is bad, cannot be fixed. That is what we refer to as failure here. So we're having this because the issue was we didn't have much adequate maintenance on these assets. And this led to loss of revenue, obviously, because if people don't have electricity, they will not be able to pay, which will indirectly affect, the revenue of the organization. So what did we do to solve this problem? We made use of GIS. We designed a tool with simply survey 123. That form captures all the details of the transformer that every engineer, a technical person would always know. So an engineer goes to the site, assesses a transformer, whether it is active or inactive. Even as it is active, you don't wait until it is out. You assess it. His own is assess it. Is it in order? Is it not in order? Answer the question and move on. And they do all that for transformers on a weekly basis. Now, at the back end, we have what we call uh, uh, risk-based analysis. A kind of risk-based analysis in the sense that we have distribution transformers, whether they are leaking oil or is it overloaded? Is it out? What is the status of the cable? Are they good? Are they bad? So this risk-based analysis was then, embedded into the data, and it appeared here as a dashboard. So if you look at this is one of my colleagues that was carrying out assessment on a distribution transformer. So zone is assess it, put your input, put your report, and move on. So this data, I made mention of oil leakage, bushes, substation, overloading. So we now generate insights from this data. And when we generate these insights, we pick the main problem. So a transformer that is escalated as leaking oil is immediately escalated by mail to the concerned engineers that are in charge of them. They go and fix it. So they are able to fix it on time without the transformer failing or packing up. So that process helped us to reduce the number of failures that we had in our system, thereby making, uh, life easy for the organization. So these are the tools we've been using. We've used ArcGIS field maps. We use Survey 123. We use Integromat. We use Dashboard. We use Geo7 too. And obviously our ArcGIS Enterprise is active. So we use these tools. Quick Capture tool, we use it for our day-to-day analysis. Instant Map, our network planning team also make use of that, designed by our unit. So this is the predictive dashboard that we used. So people go to the field, assess the transformer, as I mentioned earlier. They don't know what happens at the back end. This is what the technical managers see. They see 51 distribution transformer that are without silica gel. They also see 37 as having bad earth wires. You have 29 leaking oil. So these are what they work with, and they quickly visit those places and arrest the problem before it deteriorates to, packing up. So as at the last time I presented this was the trend analysis. You can see how it's reduced from 19 to 17 to 13 and then to 4. So you can see that there was a drastic reduction in the loss of distribution transformer, thereby engendering stable supply of electricity and energy vending, by customers, and also improve our customer satisfaction. So as of September, we're looking at working with AI, introducing Geo AI into our systems, which is what we are still working on. And then also to improve our turnaround time using utility network. We've gotten utility network that we are working with, that will help us do a lot of our analysis. I mentioned earlier that you can even, estimate energy flow on a line using utility network. It has really gone that far. So this is what we are looking at, integrating into our system. And then we have a SCADA system, which we are currently working with. So we are looking at ensuring that our GIS system interfaces very well with our SCADA system. So in conclusion, geospatial technology, the use of it cannot be overemphasized. Obviously, the advantages are just enormous. They are enormous, from intelligent data-driven predictive and preventive maintenance of grid assets to, improve customer satisfaction, robust data management solution, and improve reliable power supply. So these and many more are the advantages and the importance of GIS in the power sector. So I believe that the near future holds greater and greater and greater opportunities for us as geospatial scientists, to explore and deploy these tools, to do great things. Thank you very much for your time and for your patience, also listening. Thank you.
Thank you very much, Ubong, for helping us see how GIS has transformed the electric utility sector in West Africa. Very much appreciated. Anybody who's got a question can reach out to Ubong. I think he shared his contacts at the beginning of the session, but you can also reach out to us and we can be able to ensure and put you in touch. So up next, we move zones from West Africa to East Africa. We have Kevin Kamau, taking us through ArcGIS Indoors. Kevin?
Yes, hi. Hi, everyone. Thanks, Victor. Thank you also, Wong, for the presentation. I think it's a very nice segue from outdoor benefits of GIS to the indoors benefits of GIS. So My name is Kevin Kamau. I'm an intern here at ESRI Eastern Africa. I have an academic background in civil engineering. I'm also currently pursuing my master's at the University of Redlands in California. I have a deep passion for spatial data science and creating impactful GIS solutions. So my time here as ESRI has enabled me to gather expertise in the ArcGIS suite, remote sensing and data visualization. And I'll be using this expertise to take you through my presentation. So allow me to share my screen. Kindly, maybe Victor, you can confirm that my screen is visible.
It is.
Yeah, thank you. Thanks for that. So yeah, I'll be taking you through ArcGIS Indoors, which is an indoor space management tool that helps do indoor mapping, wayfinding, and space management. So to kick things off, I'll start with an introduction and background, basically just defining what GIS Indoors is, what it's used for, and the benefits that it brings. So this being a day of celebration of GIS, I'm sure we've heard a lot about what GIS is and what GIS technology is. So for you to be able to define or understand what ArcGIS Indoors is, then you need to understand what GIS technology is. And as you might have probably heard from all the other speakers, that GIS is basically a technology that allows us to create, manage, analyze, and visualize all types of data that are related to various positions on the Earth's surface. So what ArcGIS Indoors does is that it brings this technology and localizes it into an indoor environment, a more local environment. So bringing this GIS technology indoors enables us to do a number of things. So we're able to map out our buildings, both in 2D and in 3D, making the maps interactive. Once we're able to map out our buildings, then we're able to do a number of things. We're able to manage our facilities. We're able to navigate through our facilities, and we're also able to optimize the spaces that are available to us. So basically, organizations use ArcGIS Indoors to make indoor spaces more efficient and user-friendly. Moving on, so you might ask yourself, why do I need to do indoor mapping? Why do I need to map out my facility? So it can be said that navigating large buildings is quite hard. So once you have an indoor map of your facility, then you have a tangible way of being able to navigate through your facility. Once you map your indoor facility, then you're able to have space utilization tools. You're able to track assets. You're able to guide your visitors through your facility, and in general, you're able to make operations smooth within a complex environment. And some of the benefits that you stand to gain by mapping your facility is that, number one, you'll get enhanced efficiency. You'll also get user satisfaction. So you'll be able to improve the experiences of your visitors and of your staff. And you can also incorporate an element of safety within your facilities. So now I'll take this time to kind of give you some real world cases of where ArcGIS Indoors can make a great impact. And coming from the Eastern African office, I'll be a bit biased with examples from Kenya, but I'm sure the same can be applied to other facilities. So one major area that indoors can be applied to are shopping complexes. As an example, I'll use Two Rivers Mall in Nairobi, which is the largest mall in East and Central Africa with over 65,000 meters squared of retail space. It has stores, over 200 stores, and it has multiple level parking. Another thing that this facility sees is a high visitor volume. So there are thousands of visitors visiting this facility. So you see the need of having an efficient wayfinding tool. The facility is also It's also a mixed-use development, so it has various types of use cases. It has offices, apartments, and even recreational centers. So imagine navigating your way through such a facility. So without an indoors solution, you'd probably, if you're a newcomer, you'd probably have a hard time going through such a facility. So once indoors is implemented in such an area, then we are able to see optimized space utilization. So from the solution, we'll be able to analyze trends in visitors. We'll be able to generate data that will be able to be used for decision making by facility managers and even security personnel. Another area where ArcGIS Indoors can be used is hospitals, and I'll take an example of Kenyatta National Hospital, again in Nairobi. This is yet another huge facility. So it covers around 45.7 acres. It has a bed capacity of 1,800 and above, and again, it has multiple buildings. So you see the complex navigation problem arising. So there are multiple areas that one can access within such a facility. You have specialty wards, you have administrative offices, you have labs, and all that. And to add on that, you also have high patient and staff traffic. So such a facility has thousands of patients, visitors, workers, people doing maintenance, and the like. So implementing an indoor solution in such a facility will help you generally optimize this facility. So you'll get space utilization insights that will enable you to have a better patient care, maintenance planning, and you can also go ahead to do resource tracking. Another area where we can implement ArcGIS Indoors is in corporate office spaces. An example would be Ikigai. Ikigai is a Kenyan company that offers premium co-working spaces across Nairobi. So they have multiple locations, and they offer diverse workspaces to their clientele. So yeah, they have a variety of facilities that they offer. They offer hot desks, meeting rooms, and even event spaces. And they have a high user turnover. So their clientele is frequently booking spaces. It's frequently visiting their facilities. And so Ikigai as a premium co-working space provider will really stand to benefit from such a solution, because they'll be able to manage their space. They'll have the real-time monitoring of reservable spaces, capacity utilization, and they'll also be able to optimize their booking and in turn enhance their user experience. Another area where indoors can be implemented is campuses. An example is the University of Nairobi, which is the largest university in Kenya. It has 7 campuses within Nairobi and across the nation. So it also has different kinds of facilities, ranging from lecture halls, libraries, hostels, and the like. And of course, it serves a high population of students and staff. So implementing indoors will, number one, bring about better space utilization, user satisfaction from the students and the staff as they navigate through this facility, and also some element of security when you do real-time monitoring of access points and emergency response coordination. And finally, an area where you can also implement ArcGIS Indoors is airports. And again, the example I'll use is here in Kenya, which is the Jomo Kenyatta International Airport, which handles over 7 million passengers annually. It has the same complex navigation problem that any large facility would have. It has high passenger traffic, and so implementing indoors will provide operational efficiency, enhanced security, and improved passenger experience. So these are just some of the example areas where indoors might benefit, but there are much more examples that one can identify. Moving on, I'll move on to my proof of concept. So in order to show the benefits of ArcGIS indoors, I chose the ESRI Eastern Africa headquarter offices as my case study. And we were able to implement an ArcGIS indoors solution to centralize the spatial data that is generated by the office, and to create an interactive indoor mapping solution that will be used by facility managers to make data-driven decisions and to improve user satisfaction, and along the lines also reduce costs. So taking you through this will show how ArcGIS indoors can transform complex spaces. So like I said, ArcGIS indoors has a number of applications, and to be able to be direct, I was able to come up with this scope and objectives that you can see on your screen. So this scope basically was just to come up with an optimized spatial management system. And to do that, I set for myself, or we set for ourselves, three major objectives. Number one was to enhance the space utilization efficiency of the office. The second one was to improve visitor and employee wayfinding. And finally, to boost operational transparency and coordination, of course, using the ArcGIS indoors solution. So I'll take you through the solution architecture, basically the framework of the deployment of an ArcGIS indoors solution. So you see here, to be able to implement an ArcGIS indoor solution, you need data, you need software. So for the data aspect, we're able to collect data from various sources and in various formats. So ArcGIS indoors and Pro does a good job of incorporating interoperability between industry-leading softwares and formats, CAD formats, BIM, Revit, and the like. So we are able to easily pull data from such sources and bring them within our environment, where we can then go on and do analysis, do data enrichment, and later on be able to produce our end user products, which are three in this case: an indoor space planner, an indoor mobile app, and an indoor viewer. So with this diagram, you can kind of see how the workflow or the implementation of an ArcGIS indoors solution is done. And so moving forward, there's a bonus. You can't really talk about indoors without talking about ArcGIS IPS, which is indoor positioning system, and ESRI dubs it the blue dot functionality. So I'll take a few minutes just to take you through what ArcGIS IPS is. So what it is that it's a real-time indoor positioning system that is used for accurate user location tracking within buildings. So you can think of it like a tracker. Basically, what the technology does, it uses your phone or your handheld device to constantly ping or locate you within a building. So how then does IPS complement indoors? So when you talk about real-time navigation, this is the functionality of IPS. So IPS provides the precise blue dot navigation for seamless wayfinding. And once we are able to locate ourselves within a building in real time, then we definitely enhance the user experience. And from that, we are able to generate data, which can be used to make informed decisions. As our users are using this solution, they're able to generate data, which can be analyzed and visualized to bring up insights and concepts. Moving on, I'll just take you through the workflow, how to deploy, or how to implement an ArcGIS indoors solution. So you need to prepare indoor data that entails gathering data, the CAD data, the BIM data, the RVT data. Then you go ahead and create a database. And then from there, you can do enrichment of the data. And finally, you can do a network analysis to provide the wayfinding functionality that we see in the solution. Moving forward, this is just some of the data that I was able to pick up while carrying out the solution. So I was able to map out the office space using using a mobile app. So you scan the area and you're able to get plans both in 3D and in 2D. You're able to take that data into CAD software. In this case, we used Autodesk AutoCAD, and here we are able to enrich the data. We're able to make sure that indoor schema is followed. And to help us do this, we have the ArcGIS for AutoCAD plugin, which was quite helpful. It enables us to pull in data from Esri products and do our enrichment and quality control within Autodesk before we import it into the Pro software. So from there, I'll take you through a quick demonstration of the solution. So allow me to share a different screen. Yeah, I believe my screen is you can all see my screen. So yeah, so this is one of the solutions that we were able to come up with. So what you see before you is an indoor viewer, a web indoor viewer of our facility here in Esri, Eastern Africa. You can see that we are able to map out the entire building. So we have a floor aware building, so we can navigate to different parts of the building. So we are located on floor number 3, so we are able to filter out our visualization and have a visualization of our office, from the reception to the various desks and private offices. Another thing that you can do from the app, the web app, is that you can explore different aspects of our facility. So if you wanted to see our staff in categorized under departments, if you wanted to see the kind of facilities that our office has, you can quickly do this from this point. You can see our conference rooms. You can even view where they are located and any kind of visualization that you would want to do. Another thing that the app enables you to do is to see all the events that are being carried out within the facility. So here you can see there's actually this webinar that is going on. It actually pins you to the location and enables you to see what is going on within the facility. Another functionality that this has is that you're able to reserve spaces. So as an employee, or maybe you're a visitor or a remote worker, and you would like to book a space. So with this platform, you're able to do this. You're able to see the various spaces, workspace areas that are available to you, ranging from classrooms, social spaces, and all other kinds of spaces available to us. You can also see what has been booked within the facility. So for instance, you can see there's a booking that has been made at the cafe. There's also a booking that has been an all-day booking that has been made at a certain desk. And again, you can also book meeting spaces within the facility. Another thing that this app enables you to do is maintenance. When going through the facility, and maybe you are able to see that there is some kind of maintenance issue within the facility, then from the web app, you can actually lodge a complaint, or rather you can raise a work order, and you would do this just by selecting where you are and raising the work order, which takes you to a survey 123 form, where you'll be able to fill in the data concerning the kind of work order that you would like to raise. So let me just go back to the viewer. Yeah, so you can easily do that. You can easily do that within this software. So this is one of the this is one of the solutions that come from an indoor deployment. The other thing that you can do is you can come up with a space planner. So with a space planner, you are able to make plans or different variations of plans for your facility. So for instance, we made an initial space plan for our facility here at Esri. And what this enables us to do is basically manage the space. So you can think of, if you have like a conference center where you have spaces that need to be occupied, then you can use the space planner to allocate spaces to various individuals and make sure that there's the systematic booking and incorporation of various things. So within the space planner, you can create various workspaces. You can assign these spaces to people. You can also have reservation managers. So for instance, if you have spaces where you need other people need booking privileges from the manager, then you can incorporate this within this software. And by merging the plans, then we are able to incorporate this plan into our indoor viewer. The other thing that the other solution or the other benefit that Windows brings is that we are able then to create a dashboard that is able to like a space availability dashboard. So this dashboard can be used by facility managers and people in management to like have an overview image of what is going on within the facility. So from this dashboard, you can see that on our particular floor, we have 9 units that are reservable. At the moment, we have 2 reservations. This is what we saw within the interviewer. We're able to see the history and the details, who made the reservation, what is the reservation description. We're even able to keep a track record of what has been going on within, like, the history of bookings within our facility. There's also some added managerial functionalities that include a date selector, so you can go ahead and try and see the events or the bookings that have been made within this month. You can filter out and check, so how many within this month, how many cancellations have been made. So this brings about the capability of doing space management in a data-driven aspect. And the final solution that I would want to share is the mobile app. So allow me to stop sharing this screen and move over to the final hopefully my screen is visible.
Yes, it is.
Okay, thank you. So this is the ArcGIS Indoors mobile solution. So this is having the solution within our handheld devices. So from here, whatever we can do on the web application, we can do on our handheld device, be it a mobile or a tablet. The only added functionality that this comes with is the wayfinding or the navigation. So from here, we can do a navigation. I'll just demonstrate that. So let's say you're a newcomer and you'd like to go to the training department where Penina sits. So you'll just log into the app and use the wayfinding capability to do this. So you see, it provides us with a step-by-step directions on how we would get to where Penina is seated. So this is the added functionality that comes with having this solution deployed in our mobile apps. And of course, you can do the same. You can also raise work orders from here, the same way that we did from the web app, where it opens the survey 123 form, and you're able to submit this, and managers and facility managers are able to pick up this functionality or your work order. So I'll stop sharing and move back. Sorry, I'm doing a lot of sharing, but that's the last sharing that I'll be doing. So I'll move back to my desktop and bring this presentation to a close. So yeah, the takeaway and the call to action that we get from this kind of solution is that implementing ArcGIS indoors at Esri Eastern Africa is revolutionizing the workspace management by optimizing space, simplifying navigation, and providing real-time insights for efficient operation. So this solution transforms the building into an intelligent, adaptable environment. It enhances efficiency, collaboration, and even decision-making. So with seamless navigation and actionable insights, then visitors, staff, interns like myself, and facility managers can thrive and have a good time within our facilities. And with that, I'd like to bring my presentation to a close. Thank you for your time.
Thank you, Kevin. I wish you'd hear the applause here. I guess you've heard it from where you're seated. So thank you for the fantastic presentation. So up next, we have Valentine Anaba.
Yet.
And my apologies, I forgot to read out the profile of Ubong, but I have the pleasure of reading Valentine's. So Planner Valentine Adolsum Anaba is an experienced geospatial analyst and technical advisor with a decade of expertise in using GIS tools for spatial analysis, digitization, 3D modeling, and web development. He holds an MSc in Geoinformation Science and a BSc in Development and Physical Planning. Currently, he serves as a technical advisor at Participation, Accountability, and Integrity for a Resilient Democracy. I guess in brackets, it's paired, where he plays a key role in the design and development of the land use planning and management information system, LUPMIS, for Ghana. Valentine has a strong background in training, having educated over 250 planning officers in GIS tools for urban planning and developing innovative GIS models for quick parcel digitization and facility planning. His work has made significant impact across various regions in Ghana, including the design of digital maps, web maps, and database management systems for municipalities. Valentine's dedication to advancing geospatial technology in urban planning has positioned him as an expert in his field, contributing to the sustainable development initiatives in West Africa. Valentine, I hope I did justice to your introduction. As we say, these sides of Eastern Africa, karibu sana.
Thank you very much. It's a pleasure to be here and to also to make a presentation on behalf of the team and my people in Ghana here. So I realized we went West Africa, East Africa, and then we are back to West Africa. Thanks for the introduction. It's actually a mouthful to hear it when somebody says it, but I really appreciate the introduction. So without further ado, I just want to move forward and then start my presentation. So kindly notify me if you are able to see my screen.
We can see it.
Great. So in today's presentation, I'm going to be taking us through the use of GIS in urban planning and how geospatial data drives urban development. And some of the important concepts in this field are usually the concept of smart cities and then how smart cities are able to build the cities of tomorrow and the future that we're looking forward to. So if you look in Africa, and I'm going to be basing my examples more on West Africa and Ghana to be specific, there has been rapid urbanization, and this is bringing to us new challenges. So nowadays we have talks about climate change, environmental sustainability, transport management, and the rest. So in this presentation, I'm going to show you what urban planners do, how we use GIS and GIS data to affect the change we want to see in our cities. Now, when we take the concept of urban planning, to simplify it, anything that happens within a city, as in where shops are, where buildings are, where the road should pass, how land is used within the cities, is within the domain of urban planning. So urban planning basically looks at the process of designing and managing the development of cities and communities. And here we look at how we use the land, our infrastructure, our public space, safety in movement, access to utility, and the rest. And it usually requires expertise from people with an architecture background, engineering, economics, sociology, public health, finance. So it encompasses a lot. So basically, all the presentations we've seen from Kevin and then Yubong are also aspects that urban planners take a look at. But in this particular presentation, since my brothers have done justice to that, I'll just proceed with the elements that I have for you today. Now, in urban planning, we usually look at designing master plans, and these plans shape the way the city look. It shapes the experiences we have with the city. That's if you go to a place, you go to a city, you see the architecture, you see the layout. This is all urban planning. How we experience the city, how we move within the city, how the city is organized is all within urban planning. And some of the fundamental questions we usually ask is, what is the purpose for the plan? So if I were planning in Ethiopia and I was given an area to plan, my first question is, what is the purpose for this plan? Am I trying to create a settlement, an industrial area, a commercial area? What's the main focus? Then the next question is, what is the current situation within the area? And then where should the buildings and spaces be allocated? So how do we put things to make sure we're using the efficient use of land and there's compatibility within the land uses and then the structures and infrastructure around the area? Then how do we move people around? Are we doing more road networks? Are we looking rail, tram? We all need to understand how this influence our environment and the people to design urban spaces. Then the next question is, what basic services and facilities are required? So you realize that you go to some cities and you don't even have a health facility, or you have to travel a longer distance to access it. Urban planning looks at the dynamics in the population distribution, where people are, what resources are available, and how do you distribute these resources to make sure that they're accessible and efficiently used. Then we look at how can the area be made resilient. Now, talking about climate, talking about degradations, talking about expansion of settlements, we also need to look at how we become resilient. As cities expand, we eat into areas that were ecologically friendly. So we keep on occupying spaces that were probably for farms, for forests, for green zones. And we need to find a way to plan our cities to make sure that they are more resilient to vulnerabilities like flood and disasters like heat wave. Security is also a very important part. And these are all things we put together in designing the plan. So when we look into the field of urban planning, as I said earlier on, it brings a lot of team members and a lot of work goes into this. But GIS, through the inception of accurate data, we're able to make more meaningful decisions based on the processes and the tools that we have. And here we're going to be looking at how do we use GIS data and its technology to create smart cities. And when we're looking at smart cities, we're looking at just improving the quality of life for citizens, enhancing urban services, and then making our cities more sustainable and efficient with the use of technology and data. So my presentation is going to look at GIS, access to data, data visualization, data analysis, how we use it to plan, some simulations, and then how we can distribute this to the public for access and then the decisions as well to improve livability within cities. Now, to make it short, I actually broke this presentation into three folds. So we'll be looking at GIS data for climate and environmental assessment in relation to urban planning. We'll be looking at GIS data and GIS tools in city modeling. And we'll be looking at GIS and spatial distribution and analysis. So to start off with climate and environmental assessment. Now, one of the biggest talks anywhere in the world is how our climate is changing and our environments are also changing as well. And currently the COP is ongoing, where countries are having negotiations and making resolutions as how they can build a resilient globe or Earth, and then how we can also adapt and then manage the climate change situation. Now, one of the questions or one of the things we usually tend to do is that we tend to focus on planting more trees as a means of curbing climate change. But when you look at climate change in its critical element, the greenhouse gases that are causing this effect are usually prone from emissions. So we have CO2 emissions, methane, nitrous oxide, and then different gases that are actually causing this. And you need to find out what exactly is causing these emissions. Where are these emissions coming from? And usually we look within from our cities. How do we produce and then use food? How do we produce our energy? How do we move around in our cities? How do we operate our buildings? What type of energy do we use in cooking? If you burn coal, you release emissions. I can see someone has raised their hands. If you burn coal, you release emissions. And there's a lot to that, but not to give you a full lecture on what climate change is. What GIS is currently doing is that it allows you to have a clear look at emissions in a spatial distribution. So currently what you're seeing in the image there is a CO2 emission map for the entire globe. And currently we are highlighting an area in Accra. Now, based on this image, we see that we have about 35 megagrams of CO2 within a hectare in the space of Accra. Now, the entire map here is showing you how the CO2 distribution is. Now, in this particular case, when we are planning, we're able to identify where emissions are high, where emissions are low. We're able to investigate what are the main causes of the emissions. Is it that there's so much traffic, the type of vehicles on that street have so much emission, or what exactly is happening that you have so much emissions over there? Then we're able to plan appropriately to see how we curb the situations of that greenhouse emission. Now, this data is available on ArcGIS Pro and on ArcGIS Online, and you can pull them into your system, interact with it, and also use it for decision making. Now, the lines we see crossing from West Africa to South Africa within the ocean, those are actually emissions released by airplanes and ships as they navigate. So we can also see that the mode of transport we use actually has an impact or effect or relationship to the type of emission. And then just looking at the area of West Africa, you realize that the scale and intensity of emission is quite different based on the city. So when planning and looking at climate change issues, this type of data actually allows us to understand where are high areas of emission, and this emission we know also causes global warming, global cooling, heating, and the rest. So we're able to identify strategies to ensure that when we are planning, our cities are resilient, we're able to reduce the emissions. There's a term in the medical sector that says prevention is better than cure. So rather than always planting more trees, then we plan to see how we can reduce instances that are causing these emissions in our areas. So this is one instance in which GIS data is helping urban planning to make critical decisions during the design of plans, cities, and settlements. Another instance here, we're using GIS to conduct a land surface temperature. And with the land surface temperature map, as you're seeing here, we're able to tell the distribution of temperature within a particular place. Now, normally what the meteorological service will tell you that is that within a city, the temperature is 52 degrees Celsius or 40 degrees Celsius or 30, whatever it is. But in distribution, it is not the same. To give you an analogy, if you are in a conference room with an air condition, on that air condition, you will see the temperature at cooling. So the air condition will tell you 16 degrees Celsius. But within the room, the entire room doesn't feel 16 degrees Celsius. Those who are closer to it might feel 15 to 16, but those who are farther away from it might have a different temperature experience. And with GIS, rather than basing on full numeric statistics, we're actually able to see the distribution of that statistics in space. So here we have a city somewhere in the upper east of Ghana, and then we were conducting a land surface temperature to see the distribution of the temperature within the space. And then we realized that the lowest temperatures were around 19 degrees Celsius, and then the highest temperatures were around 52 degrees Celsius. And then the highest temperatures were mainly at high lands, that's high elevations with low soil covering. And then where we had the cooler temperatures, it was along streams or rivers, and then had a lot of greenery. And comparing this GIS data to data from the Ghana Meteorological Service from 2010 to 2022, we realized that the average temperatures were actually between 30, and then we had highest around 42, and then lower temperatures around 18 to 19. That shows that the GIS analytics that we conducted, that was showing us the distribution of this temperature in space, actually correlated with the information that was provided by the Meteorological Service. But the advantage here was that we are able to actually see that distribution within the city. And when we are planning, we're able to identify strategies to ensure cooling where there are high temperatures. Now, such an analysis is very important in sustainable planning. It's also very important in health, because then there are some health, or should I say diseases, that are actually influenced by such temperatures. So you're able to plan to ensure cooling within the environment where areas are very hot. And then we're also able to ensure that the settlements within it are not highly or adversely affected by the surface temperatures within those particular areas. Now, a third instance here, we look at its land degradation. Now, following increase in temperatures and changing in our climate, we also experience degradation in our environment. Now, whilst the degradation can be climatic, we also have instances where the degradation is anthropogenic, which means that it's caused by humans. We cut down trees, our settlements are expanding and the rest. But what GIS allows you to do is it actually allows you to assess the level of degradation in your area. And then what we are seeing on the map is the level of degradation in Ghana based on the productivity dynamic assessment from 2001 to 2022. So this analysis was done within a 20-year period using GIS data. Now, what is interesting about this is the data is compounding. So we look at each data set for each year to give you the final results. And this is usually more difficult when you are conducting an assessment and it's statistical. First of all, you can't show it and you can't explain the extent of it. And then secondly, you're also able to overlay different data sets. So here you realize that there has been a decline in our vegetation by about 10.5%, and there has been an improvement by 16%. And then we also have 49% of it being stable, which shows that once we're able to identify where degradation is, we're able to provide countermeasures. So this is one of the interesting things that GIS is providing. It shows you pictorially what is happening, the extent of it. And usually with things like this, you don't have to give so much justification. At the moment, I'm not showing you the formulas that we use in these calculations, because if I start, we'll all go to sleep. But once the map is present, we're all able to see it. And then the graph you see to the right-hand side gives you an annual degradation or deforestation within the map you're seeing. So GIS data provides certain dynamics that you wouldn't normally get in your normal statistical or descriptive analytics. And this is one of the power of GIS, and also looking at environmental and climate issues. The next one is looking at vegetation index. So whilst we're looking at degradation and then how much of our greenery has been lost, the vegetation index is able to show you the health of your greenery. So how healthy are your plants? And you use remote sensing techniques and identifying this. And once you're also able to identify the health and you see that there are areas where you have low greenery, you're actually able to plan to manage these instances. So this is a NDVI analysis. For those who specialize in remote sensing, you actually know this. But for those who are not GIS savvy, this map just shows you the health of the vegetation in a particular area. And in this particular instance, where we have the black line, that's the boundary, we're trying to look at developing a settlement plan or a city plan for that particular area. So we're now looking at the health of the vegetation within that particular area, so that we identify areas that we reserve or conserve, and then we identify areas that we could improve, and then areas that we weren't even supposed to go into. So this is another strength of GIS. Now in this image, it shows the same image for the NDVI. But now what you're seeing is an instance of the area during the rainy season and an instance during the dry season. This is not an edited image. This is what the place looks like in different seasons. But if you visit the place at any point in time, you only get to see what the situation presents to you. But with GIS data, if properly collected, documented, and archived, you can always access it to make informed decisions. Now, whilst we are looking at shaping minds and moving towards the future, we also need to understand the past and the history of our place in order for us to plan efficiently. And GIS allows you to access data, review data from the past, and you can actually go back as far back as 1980. And I think so for Ghana, the latest we have is up to 1988. I don't know for the other countries, but you can also check that, and you'll be able to get satellite images that gives you how the settlement has grown over time, what the greenery looks like, and how the shape and morphology is also changing with time and as it grows and with the different seasons. So this is also another assessment. And we have a flood assessment. And this is very difficult to do with mass or statistics. Whilst this is also more efficient when you have ground reviews or you visit the field to have an examination of the place, GIS already gives you first hand on the flood zones and the vulnerable zones. So if you look clearly at the map, where we have the deep blue, that area is prone to flood, and that's actually a dam, a dammable area. So it's a dam. Then where we have the light blue are areas that are vulnerable to flood. So that means if there's extensive rainfall, the areas in the lighter blue will be affected. And when I get to the session of simulations, I will show you how we conduct flood simulations using ArcMap to identify areas that will be immediately affected if there's going to be any extensive rainfall based on certain parameters. And apart from looking from flood assessment, we also have coastal shifts. And then here, if you take a closer look at where we have Salokope, you realize that the coastline has been shifting backwards over the years. And then now where Salokope was supposed to be is covered by water. And this is an issue also related to climate change, where we have sea level rise, no infrastructure like sea defenses within the area. This leaves those settlements vulnerable. So when it comes to the space of settlement planning and urban planning, we need to be able to make these assessments to identify the trajectory in which our environment is changing and how it affects our settlements. And this, I don't want to say can only be done with GIS, but this can only be done with GIS. So those are instances of some practical cases of the use of GIS and climate and environmental assessment. As we saw earlier in the video, GIS is like a buffet. There's a lot you can do with it, but here I just want to give you personal practical experiences that I have used GIS to conduct, even though this is not a full list of what I have done, just to show some highlights. Now, when we take a look at city modeling, GIS gives us the ability to perceive our plans in such a way that we couldn't do before. And initially, this used to be done by architects, but it took a longer period. So GIS is providing an efficiency in the way we plan our cities, how we see our cities, and then how we develop our cities. Now, I give you a first instance. This is the use of ArcGIS Urban and designing a 3D model of a city and what a city could look like. Now, this has a great interplay between urban planning and architecture, where you're able to incorporate the plans that you have for the city to see how the outlay of the city is going to look like. Now, once you're able to do this, you're also able to conduct other assessments like densities. You're able to conduct assessments like the effect on the weather, the environment, line of sight, and other numerous assessments. So this is how we use GIS in 3D modeling. So we are able to determine and shape the way we want our cities to look, even before we commence the implementation or development of those particular cities. The second instance is in topology analysis. Now, if you're not a geographer or a cartographer, and I gave you a contour sheet, it becomes very difficult for you to visualize what the area looks like, because this is basically just lines on a sheet of paper with intervals within them. Now, it's only experts that are able to understand what they're looking at. Where are the high areas? What is the inclination of the slope? What's the direction of the slope? But with GIS, we're able to model that same data to give a clearer perspective of what the area looks like. And this was done with ArcMap, and you can also do this with your ArcGIS Pro. Now, what we just did was conduct a triangulated irregular network analysis to change that line graph into a model that was more understandable. But what is more interesting is that then you're able to interact with that same data in a 3D assessment. And here we are looking at that same area that I just showed you with a satellite image overlaid to see how the settlement is faring over here. So for the purposes of planning, we're able to identify, for engineering purposes, cut and fill, where we can cut certain elevations to fill certain elevations for proper planning. We're also able to use this same information to model flood to see how people will be affected. We can also run landslide analysis to see if there were any destruction in any path or line from the forest, how does it affect the settlement? And this is one of the things that you're able to use ArcGIS and GIS as a whole to conduct assessments to see how your topology looks like. And this is also very important when it comes to planning, to ensure that we are placing the right things where they can be placed, so that we don't put a hospital on the cliff of the mountain, such that when you want to go to the hospital, you really need to climb, because if you're sick, then you are dead. But then it's important to understand the topology of an area even before you plan. And this is how GIS is helping us to analyze that. Now, here we are going to look at flood modeling. Now, what this flood model does is you provide it with information such as the rate of downpour, the rate of infiltration, that is, if it rains, how much of the water seeps into the ground, the rate of evaporation, and the topography of the place. Once you provide it with this information, you realize on the map that you're actually able to see how the water accumulates within a particular area and which structures are affected. What this allows you to do is then you're able to assess, one, the depth of the water or the level of the water that is accumulated, and you're also able to plan properly for drainage within the area as to how you use that to curb this particular situation. Now, this is something that is very important once we start talking about climate change, climate resilience, and climate adaptability. You need to be able to model instances to identify how they are going to affect the society or the community in which you are, and then also craft solutions to counter these particular instances. So in this particular case, we're able to identify where the water accumulates, and we're also able to provide for proper drainage to curb this particular situation. And you can't do any adaptability if you don't know how it's going to affect you. And that's why I said earlier on, most of the times we just go about planting trees, but we really need to understand what are the climatic conditions. We need to simulate in real time and realistically how this affects our communities so that we can then provide countermeasures as to how we are going to curb this. And this is one of the powerful tools and powerful things that I can do with GIS. Now, initially, this model with the older softwares would take you maybe 30 minutes to prep your data and then run the model. But with the new ArcGIS Pro, you're actually able to run this in less than a minute. So the duration for which you saw the video was actually the duration for which the model was run. So it simplifies the entire process for you. You just need to provide your parameters, and then it runs a model to show you how the place will look like. And this is very important for us as urban planners to identify how we are going to build our cities to make them more resilient to changes in climate. So moving towards the last end, I'm sorry for boring you with a lot of talks. We look at spatial distribution and analysis using GIS. Now, apart from just visualizing data to have clear context and then also modeling, we're actually able to do proper spatial distribution analytics in this particular space. So in normal cases, when you're reading a statistical report, they give you a descriptive analysis like within an area of 5 kilometers square, you had 3,014 structures. 2,573 of them were completed, 418 of them were uncompleted, and then 23 were not completed. So let's say you have this particular data, you're reading a report. This is what you see. Well, it provides you with some context to what you need to know. But the difference between such data and GIS is that GIS actually gives you a proper descriptive of that analytics. So on the map, I'm actually able to see which structures are completed in blue, those that are partially completed in yellow, and those that are uncompleted in red. And then I'm able to also extract the same analytics. So if I provide you with this map and this same descriptive analytics, it provides you with a wider context than if I just gave you the descriptive analytics. And for us as planners, we usually need to know the distribution of things within a particular area. So GIS allows you to identify your boundary and also show the pattern of distribution. Now, there's an analysis tool in the GIS statistical book called the Moran's Eye Spatial Autocorrelation Distribution. This tells you whether your city is growing randomly, whether there's an order to it, or whether it's just dispersed. And this is something you can do statistically, but when you include it with GIS, it provides you with a more in-depth insight as to the situation on ground, such that you're also able to make the right approaches and decision to resolving issues within that particular area. Now, you're also able to compute for densities. Now, when you look at densities, densities help you identify where a lot of people or where a lot of structures are. And when it comes to the distribution of resources, then you're able to know where to focus your resources. Now, this is very important when it comes to service delivery and then resource and infrastructure distribution. If I wanted to provide a health facility based on the densities, I'll be able to gauge a more appropriate area where to provide this facility. And this is something that GIS allows you to analyze your data, have a clear understanding of it, use this to make rational decisions. So when working with proper data and proper analytics, your information or your decisions are not based on guesswork, but you have some scientific criteria, or should I say geographic criteria, which you use in determining why you did what you did, because then you know where what is, and then how what you're doing is going to affect it. So we also have a facility assessment map. And what we see on the map here is the location of some health facilities. Now, we wanted to know the coverage of these health facilities. Now, in Ghana, we have what we call the planning standards. And the planning standards, they define how long someone should travel to access a particular health facility. So in Ghana, our ranges are within 5 kilometers. So that means nobody should have to travel more than 5 kilometers to access a health facility. So in this case, we have the distribution of our health facilities and the red maps. And then we're able to conduct an assessment to see if everybody actually has access to a health facility. And if you take a critical look at the map, you realize that those, I don't know if you can see the cursor, but those within where the cursor are don't actually have access. Even though they can travel, it means they have to travel a more longer distance to access facilities. So usually when we are dealing with service delivery, we're able to then identify those who don't have access and then provide for them in our planning. So urban planning takes a lot. And we also have a focus on network analysis and then using that to identify network densities within a particular area for the provision of road infrastructure, for travel, the distribution of resources, and for service delivery. Now, once you do this, you're able to plan cities that are more friendly for people to move around. You're able to accommodate the mode of transport within the area, and then how you are able to shape the city to ensure that there's no traffic density at any point in time on your road. So looking at all of this and the power of GIS, it shows that there has been a lot of phenomenal stuff that GIS is helping in the field of urban planning. And I'm sure from my presentation, you can tell that it doesn't only affect urban planning, but it also cuts across many other disciplines. Moving forward and the use of GIS, I just want to let you guys not to restrict yourself to the use for GIS in only geography. I've had instances where people tell me GIS is for geographers, so we don't need to learn it. But the first instance and the use of GIS was actually in public health when it was used for a cholera case. So the extent to the use of GIS is limitless. The only limit to it is the way you perceive how you use it. So today, as we celebrate GIS Day and then shaping minds and shaping the future, I want to encourage all of you within your disciplines to also identify how you can use GIS in your fields. Thank you very much for your attention. And if you have any questions, you can drop them in the chat. I'll be willing to address them for you. All right, over to the moderators.
Thank you, Valentine, for that informative session. And also thank you to all the speakers. I want to hand over this session to our co-organizers, the team from Sambus. Samuel.
Yeah, hello, Victor.
Take it away.
Can you hear me?
Yes, I can.
Wow. Wow, wow, wow. Also, we've come to the end of today's GIS Day webinar. I mean, it's been great. I've truly been inspired. I've truly been inspired. I'd like to express my heartfelt gratitude to everyone who has joined us today. It has been an inspiring session under the theme Mapping Minds, Shaping the World. A special thanks to our incredible speakers. And I want to believe you will all agree with me that they've been very inspiring and we've learned quite a lot. For sharing their knowledge and showcasing how GIS is driving innovation and solving real world challenges. Your contributions have been truly enlightening. To our organizers, Esri Eastern Africa and Sambus Geospatial, Thank you for making this event a success. Your efforts continue to foster collaboration and build capacity in geospatial technology across industries. To our participants, GIS is more than a tool. It's a way of transforming data to solutions that impact lives and shape our world. Let us all continue to innovate, explore, and use GIS to create a better future. As we celebrate 25 years of GIS Day, let this milestone inspire us to keep pushing boundaries, finding new ways to harness the power of GIS. Thank you for being part of this journey. Until next time, keep mapping minds and shaping the world. Happy GIS Day, everyone.